Assalamualaikum and hello. My name is Siti Amira binti Johari. My metric number is AA 2050. Okay, now I will continue my group presentations. For the part of introduction for the project Raft House, floats are the most common natural calamity around the world. Flood is coastal location are frequently produced by heavy rainfall, quick snowmelt, or a storm surge for a tropical cyclone or tsunami. Okay, there are three common types of flood, which are river floods, flash floods, and coastal floods. The idea of designing and building a raft house is a way for people in flood-affected region to protect their belongings from being wrecked by the floods. During the non-flood season, the small raft house serve as a resting hut, while during the flood season, it serves as a rescue to people. When severe weathers come, the raft house will float whenever a flood threatens, providing protection for people and their belongings. It was created to improve catastrophe resilience in local communities and could be used to store food, water, medicine, and sanitary material.
Hello, my name is Martin. I would like to present about the required information in our raft house. So we divide the raft house into 4 spaces, which is room, the dining room, living room, and also the laundry. So first of all, in the room, we got 1 queen size bed, 1 double-decker bunk bed, 2 wardrobe cabinet, 2 tables, and also 2 chairs for the study. And next, in the living room, we got 1 sofa set with table, 1 computer, and 1 television. In the dining room, we got 1 electric kettle, 1 multi-purpose cooker, 1 refrigerator, 1 oven, 1 dining table and chair set, induction cooker, and also kitchen cupboard set. So in the laundry, we got a washing machine, drying rack, microfiber mop, and also a water tank. And in each room, we got the ceiling fan for each room.
Hi, my name is Ong Kang Nan, and I will explain the sizing of our raft house. As you can see on the left hand side, the floor plan of our raft house. Our raft house is planned to be 5.49 meter wide and 18.29 meter length, and the base will plan to be 6.71 meter wide and 22.86 meter length. And our raft house is divided into several areas. The first one is living room, the second one is dining room and kitchen, the third one is corridor, the fourth one is bedroom 1 and 2, the next one is toilet, and the last one is laundry, and all the plan size and dimensions are listed on the table on the right hand side. After deduct the area of the raft house, there is a total 53.75 meter square left as garden space for residents having outdoor activity.
Hello, my name is Eng Sao Tang. I'm going to present about building material for the buoyant components. The plastic barriers are chosen as the rough material because the plastic barriers have good buoyancy and are lightweight. By having good buoyancy, it has a higher tendency for a body to float or to rise when submerged in the water. Hence, plastic barrier can provide higher buoyant force to the raft. The lumber is chosen as the rough material because lumber can be screwed together with plastic barriers and provides good strength. Through research, the floating house built with plastic barriers is commonly fastened together with lumber because lumber can be easily connected using nails, screws, bolts, and connectors.
Next, build of material of raft house. Besides consider the weight of the household item, we also need to consider the structural component of the raft house. So in our raft house, the structural components are window, door, sliding door, floor, sloping roof, floor tub for toilet, wall, and fence. It is difficult to explain each of the structural components in detail in this video, but I will only explain one for an example. The material selection for window frame is fine because it is structurally strong but not overly rigid. And the material selection for glass is tempered glass because it is 4 times stronger than untreated glass. The way of calculating the mass of the window frame is by using software application SolidWorks. and the mass of the glass is calculated by using the online website Glass Weight Calculator. After inserting all the data, we get the result of a window frame is equal to 14.31 kg and the glass is equal to 7.354 kg per glass. Since a window have a window frame and two glasses, so the mass per item is equal to 29.02 kg. And there is a total of 4 windows in the Raft house, so we need to times 4 and the total mass is equal to 116.08 kg. After calculating the weight of each structural component, we total up and we get 14,703.17 kg for the structural component of the Raft house.
For loading capacity, to determine the number of plastic barrels used for building the raft, the horizontal and vertical dimension of total plastic barrel and lumber have to be found. By dividing the length of the raft by the horizontal dimension of the plastic barrel and lumber, the total plastic barrel and lumber that can be arranged in the horizontal plane of raft will be determined, which is 23 sets. The total plastic barrel and lumber that can be positioned in the vertical plane of the raft will be determined by dividing with the weight of the raft by the horizontal dimension of the plastic barrel and lumber, which is 10 sets. Hence, the total plastic barrel and lumber that can be stacked in the raft are 230 sets. In order to calculate the loading capacity of the raft, the mass of the raft needs to be excluded. The total plastic barrel mass is 230 sets times 9 kg, hence the total plastic barrel mass is equal to 2017 kg. We all know that the density of air is 1.225 kg per meter square. Hence, the total mass of air inside the barrel is 69.91 kg. Hence, by summing total mass of plastic barrel and air inside the barrel, the mass of raft can be determined, which is 2139.91 kg. Next, find the buoyant force by using formula buoyant force equal to rho Vg. The buoyant force provided by plastic barrel is equal to the sum of raft mass, and the maximum load capacity can be withstood by raft. The density of rainwater is 1000 kg per meter square. Hence, substitute buoyant force equal to rho Vg and W equal to mg into the equation, and substitute a V equal to AH into the equation and divide it by G. Thus, when the plastic barrels are fully submerged in the water, we can know that the maximum load capacity can be withstood by raft at 74,473.73 kg.
From the calculation done above, we can make some conclusions. First of all, is the total weight of the household items is equal to 1,485.44 kg. The maximum load capacity can be withstood by Raft house is equal to 74,473.73 kg, and the total mass of the structural components of the Raft house is equal to 14,703.17 kg. So in order to determine the buoyant force of the Raft house, we need to deduct the total weight of the household items and the total mass of the structural components of the Raft house from the maximum load capacity that can be withstood by the Raft house, which are 74,473.73 kg minus to the total of 1,485.44 kg plus 14,703.17 kg. So we can note that the Raft house still can withstand 58,285.12 kg. And according to the research paper we found, we assume that one people is equal to 62.65 kg. There are 4 people living in it, so the total weight of people are 250,000.6 kg. And after deducting it, it still got 58,034.52 kg left. So the Raft house is considered safe.
In the section of engineering drawing, we will see the 3D model of our Raft house. So on the left hand side is our schematic diagram of our Raft house, and on the right hand side is the isometric view of our Raft house. Because our roof is inclined above 5 degrees, so the minimum height of our Raft house is 3.18 meter, and the maximum height of our Raft house is 4.78 meter. Next, I will show the 3D model of our Raft house in SolidWorks.
Okay, for the calculations, with application of Archimedes principle, the Raft house can save household item and increase the chance of survivability during flood occurs called being plastic barrels chosen as the Raft material because the barrels have a good buoyancy and like this. For the Raft house design, the Raft consists of 2 bedrooms, a toilet, a living room, kitchen, dining room, corridor, laundry room, and the last one is a garden space. We know that the upward buoyant force experienced by an immersed body is always equal to the weight of the water replaced by the immersed body. By applying the formula of Archimedes principle, the maximum load capacity can be withstood by the Raft house can be calculated, which is 74473,000 at 0.73 kg. In our design, the total weight of all household item is 1485.44 kg, and the total mass of the structural components of the Raft house is 14703.17 kg. By reducing the total weight of the household item and the total mass of the structural component of the Raft house is still able to withstand 285.12 kg. By assuming 4 family members with every range, the Raft house will still have a loading capacity of 58034.52 kg. It's a big deal to let a family of 4 people live in this Raft house. Thus, the material selection, design, and calculation discussed above will enable us to construct a secure and comfortable Raft house in the future. That's all from me. Thank you.